Nodes Engineering Hour, and this week we're here with 𝗗𝗲𝗍𝗍𝗍, also known as Daniel 𝗗𝗍𝗍𝗍𝗍, and we're going to be going over Nix. So Nix is a cool new technology that a lot of embedded and IoT developers are using in their development environments, and Daniel's going to walk us through it and explain how to use it and how it's different from other established technologies like Docker. So we're in for a treat. He's got a couple of demos. It's going to be a lot of fun. Before we get started, as always, I want to give you a few housekeeping items to make sure that you can get and stay up and running during the course of the event. So if you're in the webinar platform, there's a menu bar at the very bottom. It's going to allow you to go through a help wizard if you can't hear anything, can't see anything, any of those types of things. Some of the common culprits for not being able to participate in the event from a multimedia standpoint is bandwidth. So if you're pulling less than 5 megabits per second down, you might want to try to switch your network because otherwise you're probably not going to have any success no matter what steps you take. Some other things that you can try if you're having issues, regardless of your platform, are refreshing, checking what other applications are open and closing any of those. It might be bandwidth hogs or resource hogs. And of course, if you try a bunch of those things and none of them work, you can always feel free to direct message me. I'm at 𝗗𝗍𝗍𝗍𝗍 or Brandon Lewis, depending on the platform you're in. And I'll be perusing around and making sure that I answer any questions on how to get you back up and running and watching the event. I do want to encourage you to ask some questions. So drop anything that you have to say or are curious about into your native chat platform. Again, I'll also be floating around and pulling out any comments, questions, or discussion points from those, and then filtering them back into the chat channel so that myself, Daniel, and the other members of the community who are attending can participate in your ideas. Beyond that, we do have about a half an hour worth of presentation today, and then Daniel's got to run, so we're going to try and squeeze in another 10 minutes at the end there. But please keep those questions coming in. And other than that, I don't want to keep us too short. Besides to mention that if you like what you see here and you want to talk to folks like Daniel, who've got a lot of expertise, make sure to join us in the DevHeads community at discord.gg/DevHeads. With that, I'm going to jump into the chat and we're going to hand it off to Daniel and we're going to learn a lot about Nix. So Daniel, why don't you take it away?
Yeah, thank you, Lewis. Yeah, my name is Daniel. So I am an embedded developer. I want to introduce you to Nix. It's not that new technology. Nix has been around 20 years already, but I started using Nix for embedded development in the last 6 months, something like that. So it helps me a lot to keep
It's
my.
New to us, Daniel. It's new to us.
So I'll just start with the presentation. I will keep the presentation as short as possible because I think we can learn more if we have the interaction between questions and answers. So let's start with the beginning. So usually when we develop our application for embed, we use first a computer with the operating system. We use a specific IDE, VS Code, Vim, whatsoever, our tools for everyday development. And then we have the specifics for the application. For example, compiler, GCC, we have the build system, CMake, Ninja, whatever, and also some RTOS or the embedded Linux, whatsoever. No? So the idea of Nix is Nix helps us to manage the package or libraries dependencies we need to build our application. So, and the best thing is Nix is also a programming language. So at the end, you get a file where you define every step you need to reproduce your building, your application. So at the end, you can have a file where you can share with your colleagues or friends. If you use this file, you can build the same application as me. So, for example, we have here a hello world. As I said, Nix is you can see as a container. Let's start with this idea. So I have a simple application here. I will share my screen. I think I wasn't sharing. Sorry. So I'll share my screen here. So I have a small application here. Basically, it's a hello world example. So I just print some information about the compiler, about the libraries I'm using. So I will use Nix to compile this application using different versions of the compiler and libraries. For example, I already compiled everything because it takes some time. I'll show you the outputs. So we can see here I compiled the application using GCC 9.3, also Boost, different versions of Boost library, Poco library, also different versions. So as you see, it's quite, you have a lot of flexibility once you got everything set up. You can also use Nix, for example, as a virtual environment, like in Python. You have what's called Nix shells. You can use, for example, if you want to use Python, some version, that doesn't exist. You just make always mistake. So, and then you got Python. You are using this version. If you want another one, just go off the shell. For example, I'll use, I think you can use this one. Yes. So now you are using Python 3.14. So as you said, it's quite easy to change between versions, either using that shell like I use here, or just building using a script to build with different versions. So that's basically a quite small interaction about how to use Nix. So why using Nix if you're already using Docker? So I've been for years a Docker user as well, because it helps me to maintain my deployment always the same. But the thing is, Docker is great for deployment. I mean, for example, CI/CD pipelines. If you have a web app, you can just deploy in Docker, send it to Amazon Web Service, use Kubernetes whatsoever. So it's a runtime deployment. So Docker for this use case is amazing, no question about it. However, if you want to develop applications, in our case for embedded systems, it's quite heavy. So basically, if you are not familiar with Docker, so Docker is it's a container where all the dependencies are inside as well. As I said, for example, the compiler, the library you need, but also what's inside of this container is a base image. Usually it's Linux. So because of this base image, the container is quite heavy to run. So you need a lot of resources, basically a lot of RAM to run, if you want to run multiple containers. For example, in the first example I gave with Nix, in which I compiled Hello World, I compile different versions of GCCs, and I use different versions of Boost library. So imagine doing the same with Docker. You will need at least 10, 15 containers. So you can either you have all of the containers running at the same time, or you just switch. So you have to delete the container or turn it off and then start a new container. So it's, as you said, as you saw, when I compile the Hello World example, it's just quite fast, and I have all the versions already. And the other thing is, as I said at the beginning, Nix is a language, a programming language. So you have a file where you define exactly which version you need for a specific library. So every time you share this file, you will get the same exact result. With Docker, it's not the same, mainly because usually when you, this is an example of a Docker file. That's the file you use to build containers. So usually you have somewhere in your Docker file an apt get update. So what this command does is basically pull the latest package, and every time you create a new container, you basically doing an update. So there's no guarantee that you always have the same. For example, if you build the Docker container today and then next year you try to build the same container, probably because of this update, you will get another version of your packages. So at the end, there's some chance that your application that you were running 1 year ago is not working right now. But with Nix, that doesn't happen. So you have the same because you define the file. I will show you later how do you define that. So basically in Nix, you define the versions, even the hash. For example, so the hash, like in Git, when you do git commit, you got the hash. So this hash is unique. So for Nix, you get the same. So basically, if you run the Nix in 1 year, Nix will check this hash and get the correct version. So there's not risk to have different binaries. So at the end is basically, some people say, in Docker you could do the same, but it's not that easy as in the case of Nix. There is an image here that basically shows how difficult it is to do it in Docker to get the same binary every day, even in different machines. And so in Nix, it's just one file. It takes some time to do the file, but when you got it right, you can just forget about it. As I said, there's no risk to that. So if you build your application using one specific version of Nix, using one specific version of packages, it will work until the end of the time. So there's no risk about that. So as I show you, there is some, I will share again my screen to do some. So I show you here with the Python example that there is some Nix shared here. So I use it, for example, if I want to do some small tests using Python for whatsoever, but that's not the way you use Nix usually when you do the development. What you usually use is what's called Nix Flakes. So what's Flake is a tool based on the Nix programming language to define your build environment. So I will show you an example of how this Flakes looks. So this is my repository. So in my repo, I define a Flake Nix file. So the file looks like this. There is some description. You can think about like if that file were a JSON file, just a big. I have a description here, some inputs. For example, I'm using Nix OS version 24, and then I define my system. In my case, it's Linux. I define which Python package I want to use for my deployment. And then I start defining the dependencies I need to build my application. For example, I use CMake. I also use DTC for device tree compiler, Python, GCC here, also for debugging OpenOCD, and then some Python packages I need. So I use pip, for example, to start Zephyr. And other tools also for, in this case, for the MCU boot, I also require some Python packages. So I just define everything here in my Nix file, in my Flake file. As you see, it's quite simple. So it's not that complicated. Actually, you define a system and descriptions and inputs and all the packages you need. So, and then you can just share this Flake Nix file in Git with your friends whatsoever, and they will get the same result as you. I will continue with the demo then. I forgot about that, sorry. So since this channel is about embedded development, I think it's quite useful to see how does it work using Sapphire OS, because I think many of you know already what Sapphire or Zephyr whatsoever is used for embedded. It's a real-time operating system that's supported by the Linux Foundation. So it's quite popular right now. So, as I said, I have defined here my Flake Nix file with all the dependencies I need. And what I also define is a shell hook. Basically, this shell hook does is every time I get into my development environment, I execute some commands I want. No? For example, in this case, I use west update, west init, and some scripts for that I develop for me. So as I said, and to use this Nix Flake generates a Flake log file. I'll show you the content. So as I said at the beginning, there is every time you build a Nix environment, you generate a hash. So in that way, your environment is unique. So as I said, because it's unique, you can just share it, and you will get the same result, because every time you build, every time you get in your Nix environment, Nix will check, okay, you are using this hash, here also extra information, and I just pull this information from my repository. So as I said, that guarantees that you will always have the same build environment every time. And to development is as simple as just executing this command, nix develop. And then Nix will search in the next Flake Nix file, see what you have, and start executing everything. For example, I already I executed already once Nix develop, because I didn't have Sapphire in my Nix environment, so it took some time to install it. And once you got it, it's already there, and it doesn't take more than a few seconds to load everything again. So I will show you what I installed. So you can see here that Nix tried to install some packages required for West. Also set up tools that the Python packages I defined in my Nix Flake file. Also here, I have some scripts that updates also Sapphire in case it's old or in case I change something. So that's what you see here. Check in all if something is new or it needs to be updated. And now I'm already in Nix, as you can see here, you're in Nix. Now I can just develop as you usually do with Sapphire. I have some projects here. As example, I have a hello world. I just can do with west build. Oh, sorry. I already built the system. So I start from scratch. And I'm building right now an application for this specific microcontroller, the NF. So it takes some time to build. And now I can just deploy my image. It's already there. I don't have any microcontroller here right now, but you can, if you want, you can use West Flash and it will work. I have another application with another, using another microcontroller. For example, I'm working in updates over the air, so I can build this application again. I prefer to use scripts because the commands can become quite complicated. So just keep with me. So this build is basically West's build with more parameters. So I'm building also my system for a different microcontroller. So I'm just using Zephyr as you usually use in your your development environment. It can be Linux, it can be Docker container, whatsoever. But as you see, it doesn't make your development more complicated. Actually, it makes the development easier. For example, I'm right now in the Nix environment, but if I switch to another tab, I'm in my Linux system. There is no conflict between Nix, my system. Even I can start another Nix shell if I want. It's quite heavy right now with the building, but I'm here. I'm using right now Nix with Python, with this Python version, and there are no conflicts. So if I don't want to keep working in my Nix environment, I just exit, and I'm back in Linux. If I want to get inside my development, it takes some seconds because my checkups take some time. So I'm already in Nix. So it's quite easy to get in the development environment and get out. So it's not like Docker in which you have containers and sometimes you have to stop the container to start a new one. If you change something in your container, you have to build usually the image again and then deploy the container. So it's quite complicated. It's not that easy as just one command. So that's what I wanted to show you. Share. So Nix have a lot of advantages and benefits, but it's not that easy to learn if you want to do some complicated stuff. So the learning curve is really steep at the beginning because you have to understand the syntax. It's not as easy as Python or C because Nix uses functional programming. So you have to think a little different about that. Basically, each instruction in your Flake or in Nix shell is a function. So if you call different lines, each line generates a function. So you have to think a little different when you are writing your Nix, your Flake file. But as I showed you before, for us, for embedded development, we don't need a really complicated file. As you saw, I just defined my operating system I want to use, the packages I need, some hookups for my shell that I want when my shell started. It can be print, welcome to Nix shell whatsoever, but it was quite simple. So for us, like us, embedded development, we don't need too much complexity. So in this case, Nix, it's quite friendly for us. So here to finish the presentation, then we start with the questions. So as I saw you, Nix helps you to build the same binary every time because Nix use hashes for each packages. So there is guaranteed that you will get same result regardless of if you're using Linux or Mac. So it's quite lightweight because there is not base image. So there's no Alpine or Ubuntu that you have to call, and then you have to call extra package like in Docker. No, it's quite lightweight in this case. And every time you install a package using Nix, there is a hash for each package. So even if you make a slight change, Nix will generate a new hash for this new update. So you will also get the old version in your system. So even if you break something, you don't have to worry about it. Just go back to the latest version in which everything was working, and you're safe. So you can break things without worrying about your system. So you have this safety also in Nix. And also, as I show you, for us, we need a small subset from Nix that I hope you get the idea that it's quite simple to work with that, and you get a lot of benefits because you have this isolated environment. You can switch between environments quite easy. So as show you, once you are in the Nix environment, you just work normally that you would do in Linux or VS Code. So that's all. If you have question, I'm open to that. I see in the chat.
Yeah, there there are a couple of discussion threads going. The first one that I had a question about is, Daniel, I know you're like a proper embedded developer where you play with things even if you're not on the clock. Are you using Nix at all in your professional environment at work?
Yeah, sure. Yeah, sure. Because I mean, in my company, nobody uses Nix, but since Nix just manage my packages, if I can keep working with my colleagues and they don't even notice they use Docker or they just use virtual machines and do whatever. So as I said, because it looks complicated. Some people I say, yeah, I don't have time to learn something new, but I don't know.
Because there are questions that start falling on top off of this, right? Which are a lot related to, like, if you are capable of using it in a professional environment, or if you do use it in a professional environment. You said you're working with like a lot of OTA stuff. Can it be? We're talking about development, but what about deployment? I mean, I'm assuming it's just as applicable there.
As I said, I use Nix for building stuff. For deployment, I use Docker. So, for example, the CI/CD pipelines in GitHub or GitLab, I just use Docker in this case. So there are two different use cases.
Yeah.
So
go ahead.
Yeah, exactly. For Nix, I need a machine where I can build an application. For example, in embedded, when you deploy something, you deploy on a microcontroller, but you develop on a PC. So it's basically the same. So Nix is for development, and Docker I can use for deployment on the cloud.
Okay, perfect. We've got some questions coming in here. Let's see. Everybody, I dropped, by the way, the link to Nix OS on in the chat channel, and then there's also Daniel's slides in the handouts section. If you go to apps and then handouts, you'll be able to find those and download them if you'd like. If you're in the web platform, if you are on another platform, too bad. Sorry about that. So Asmir asks, what's your recommendation on distributing binaries on embedded Linux, which are built using Nix?
If, for example, if we are talking about building the binary, I just you can just clone the repository that has the Flake or Nix file within and just run Nix develop, and everything will be the same as you had. So, but if you're talking about building in some continuous integration pipeline whatsoever, then I will just use Docker or GitLab CI/CD I don't know if that answered your question.
Yeah, Asmir, if you could get a little bit more specific, we'll come back to that. Okay, perfect. Says it does. Brian posts here. I'm assuming this was in response to Asmir, I believe. I'm assuming he's building a container, then the embedded system is pulling the container. That was the question. Daniel, do you have your the code from the demos that you used up on your GitHub anywhere?
Yes, but private, because I'm developing some my own application. So, but okay. You can, if you, for example, I can share something quite easy. Share this. So I hope you can see my screen. For example, I have a blog, 𝗗𝗶𝗶𝗀𝗀𝗀𝗀𝗀𝗀, so I deployed the blog using GitHub Pages. But when I write something on my computer, I just use Nix for that. For example, what I just need to build my blog is just a couple of packages. So you can check here the repository for my blog, 𝗗𝗶𝗀𝗀𝗀𝗀𝗀𝗀𝗀. It's in GitHub. Check the Flake Nix file. You can start with that, or there is also okay, hello world. So you can also check this repository. I just posted in the chat. So where is, I think is, where is this here? Sorry, just posting in the chat. So here is a good example. So you can check it to use for, that's more complicated than what I have here, but you can start with this once you understand what I did here. So there are some packages here. The shell hook basically is what I want to execute when I get into the shell. So the idea here, it's basically the same, but a little more complicated. So you can check this repository. There's also, if you just copy that on Google, there is a blog posting from Jake. I don't know how to pronounce that. So they also explained how you can use Nix for C projects. And if you, for example, if you are using, if you want to use Arduino, you can also use Nix for that. For example, there is a package called Arduino 𝗗𝗗𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃. So it's so if you use this package and you get in the shell, you can start developing things for Arduino. For Python or C projects, it's basically the same. So if you are using cross compiler, you can also use Nix for that. So in this case, I'm using the compiler that is ARM, or if I want to do just local compiling, I just use CCC. So the idea is basically you get used to create these shell files where you define everything you need for the development. So so every time you get in the shell, you will get always the same result. So that's basically the idea. And as I show you, for one application, if you have one application using the same versions on everything, you just the Nix file is not that complicated. So as I show you many times, you define packages, you define whatever you want in your shell hook, and that's all. It's not that complicated, actually.
Awesome. Daniel, this is always really cool when you come on and share your sort of adventures. I really appreciate it. Looking forward to more of that in the future. You should definitely check out 𝗗𝗶𝗃𝗃𝗃𝗃𝗃𝗃, the blog. A lot of good insights from Daniel and just his sort of adventures as he goes through building for embedded and IoT devices. I just dropped into the chat link to the next upcoming webinar. We've got a lot of stuff we're working on in the background right now. So we're doing every other week where we're doing a session. In a couple of weeks, we've got Imesh who's going to be walking us through some CAN firmware implementation on ST-M32. And then he's going to continue that series out through the summer and then eventually work towards CAN-FD. So if you're interested in that sort of low-level field bus type protocol, definitely you're going to want to check that out. And then, of course, Daniel and then a bunch of other people, Imesh, Ming, et cetera, are all in the DevHeads Discord server. So if you go to discord.gg/DevHeads, I'd be happy to chat you up. And if you need to come back and reference this presentation or anything, like I said, the handout is in the platform here, but also this will be up on YouTube, on the DevHeads YouTube, and you'll be able to watch it in its entirety after the event. So thanks a lot, Daniel. Always some good stuff. And for everybody who joined, thanks so much, and we'll see you in the server.
Yeah, thank you also. Have a nice day.
See ya.
Yeah, bye.